I'm Alex, and today I'm going to be talking about the 5 properties of water. So the first one I'm going to be talking about is the polarity of a water molecule. So a water molecule looks something like this. So this red represents oxygen and the 2 white represent hydrogen. So as you can see, this bent shape in the water molecule is essentially what causes it to be polar. So when you have a polar molecule, that means that there's a large difference in electronegativity, which is essentially an element or atom's ability to attract electrons. So here, as you can see, oxygen has a much higher electronegativity than these hydrogen atoms. Thus, that's why this shape is bent and making the molecule polar. So this has a very important role in nature because being a polar molecule of water, this allows water to be considered the universal solvent. So I'm going to demonstrate this in a little experiment. So I'm going to take a glass of water and I'm going to put some salt, which is also known as sodium chloride, NaCl. So I'm going to put about a teaspoon or tablespoon of salt into the water. I'm just going to mix it a little. So as you can see, the salt is dissolving into the water. So the reason why the salt dissolves is because a water molecule is polar. So let's take NaCl, for example. The orange represents a sodium ion, or a sodium, and the green represents chlorine. So essentially, this water molecule is going to come, and the oxygen is going to interact with the sodium, and the hydrogen with the chlorine. And what happens is when the water interacts, these two, the NaCl becomes an Na plus ion, the sodium, and then a Cl minus ion. So that's basically what you see here, the NaCl dissociated in the water, and that's why it is dissolved. So the next property of water I'm going to be talking about is hydrogen bonding. So basically what hydrogen bonding is, it's a force that takes place within water molecules, and this is part of the reason why water has, if you place a paper clip on water, the paper clip floats rather than sinks, because the water molecules are cohesive, which means that they are able to stick together due to this hydrogen bonding. So if you take 2 water molecules, you can see that there's going to be a force between the oxygen and the hydrogen atoms, which is going to allow them to stay close together. So another property of water that I will be demonstrating is cohesion and adhesion, and also surface tension. So basically, adhesion is the ability of water to stick to other molecules, and cohesion is the ability of water, which I just talked about, to stick together via these hydrogen bonds, as you can see. It's like a force between these atoms. So if you take a penny, I'm going to use this pipette, and what you're going to do is take the pipette and you're going to slowly drop water onto the penny, and you're going to count how many drops you get. So let's see. 1, 2, 3, 4, 5, 6, 7. So you want to see how many drops of water you can get before the water overflows. So if you look here at the penny, you can kind of see how the water is about to overflow off the penny. However, it's sticking together. The water molecules are sticking together so it doesn't overflow. So this is basically due to adhesion and cohesion, how the water molecules are able to stick to the penny, but also the water molecules can stick together to stay on the penny. And then basically to finish the experiment, you just count how many drops it takes until the water overflows. And then you basically see how many times you can do that, and maybe test, you can test salt water to see if that makes a difference in the drops. So yeah. So that's adhesion, cohesion. And another property of water that has to do with adhesion and cohesion is capillary reaction. So basically capillary reaction takes both adhesion and cohesion in order to have water defy gravity. So what happens is, let's take a tree for example. Water molecules are able to go up from the roots of a tree to the leaves and to the top of the tree because of capillary reaction. And this water defies gravity because a water molecule is polar. It's able to stick to areas of the trunk, which is also polar, to allow the water molecules to move up, while the water molecules are also sticking together. And the last property of water is specific heat. So basically, specific heat capacity is, for water, at room temperature, it's 4.18. So this number essentially means that it takes a certain amount of heat to raise the temperature of water by 1 calorie. So an example of why specific heat is useful is in the human body. Humans have to maintain a certain temperature to stay alive. So with this specific heat capacity, it takes a lot of energy to change temperature. But because it's so high, humans are able to stay in homeostasis with a constant body temperature. So yeah, that's the last property of water. If you want, you can try these experiments at home, and you can also try a capillary reaction experiment through a technique called chromatography. I won't be demonstrating it today, but all you basically do is you dye the tip of a celery stick and you place it in water, and then you wait a few hours or a day, and you can see that the food dye goes up the celery stick due to capillary reaction. So yeah, thank you for watching.